Welcome everyone for today's live event. So yeah, today are already familiar that from all the media hype that we have recently launched a new generation for the previous AC ELWA, and now we are with the new one AC ELWA 2, and I will be your host Talal Bhatt together with my colleague Reinhard. So together we will be introducing you with our new product. So, moving how our team is and what we will be discussing in this live event of today's, I will introduce you about our team from MyPV and what is our history, and moving on to the details of today's event. So, yeah, the company is managed the managing director is the person from the left side, Dr. Gerhard, and has a experience from his management as a solar inverter companies, and with his experience in the solar thermal, he was able to vision a company like my PV. And Reinhard is involved as a product manager for my PV over the year. He has experience from solar thermal, and over 6 years, he is handling product management at my PV. And about myself, I'm electrical engineer and handling the international sales for my PV. And moving on to our history, so we are relatively young company. We started as a company from since 2011, and we started as a the vision for our company was a PV based water heating. So we developed our first product in 2013 with the ELWA. You are familiar, the DC solution. And over the years, we grew with the number of products. The AC ELWA is already in the market for 6 years. And then we have the AC Thor, the three-phase system. Last year, we had the new building, the new headquarter, and this year we launched the next generation of AC ELWA which is called as AC ELWA 2. So that will be the topic of today. And as I said, we are an Austrian-based company in the province of Upper Austria. The city itself is called Neuzeug. So we are manufacturing our products here in the building you are seeing as a in the picture. So it has won number of awards. The famous one is from the Energy Globe. So that means it uses relatively less amount of energy. It is dependent upon the less amount of energy from the external sources. So it's more dependent upon the PV based system, which you can see it's surrounded from the rooftop to the facade. All are surrounded with the PV panels, which enables it to be self-sufficient. And furthermore, the energy consumption from the building itself is really low. And more details, if you are interested, can be easily found on our homepage or get connected with us. So I will be handing over to the Reinhard for rest of the details, and I will see you back at the end with the details from the delivery times, the all other details which are related from the sales side. So Reinhard, over to you. And from my side, I will be in the chat for your questions and answers, and the rest is with Reinhard. Over to you.
Thanks a lot, Talal. And also from my side, ladies and gentlemen, welcome. Thank you for your time, and thank you for participating in today's webinar. While Talal was introducing MyPV and our history, it's a pleasure for me to show you our new product, which is called AC ELWA 2. MyPV, as a manufacturing and a development company, has designed solutions for power to heat applications, power to heat systems in residential buildings. You maybe have heard about the topic of sector coupling, or Sektorkopplung as we call it in German. It's about using renewable excess energy or excess power not only for electric appliances, but also for thermal appliances, for example, hot water preparation or electric space heating or EV charging. So MyPV has focused on the sectors on the right. We dealing with power to heat systems, and today it's all about hot water heating with excessive photovoltaic power. As a manufacturer, we are also providing our solutions to apartment building projects, to commercial building projects. Let's take a look on this slide on the energy demand that we have in a single family home. So for an average European household, it's around about an energy consumption of 4,000 kilowatt hours to supply your electric appliances in the single family home, including the light and all the appliances, all the devices, from the dishwasher to the washing machine, TV, whatever. And most of the people are aware of this amount of energy because one time per year we receive the energy bill from our energy supplier. Nearly no one knows that we are requiring nearly equally as much energy for hot water heating. This is the case for a four-person household. And this means that we can easily also include this energy segment of hot water heating into our photovoltaic power installation. And MyPV offers the technology to include this kind of, let's say, thermal storage for PV power. Okay, so it's about saving energy, about storing energy. The most common way to store energy is, of course, a stationary battery storage system. For a single-family household, typical storage capacities in batteries mean a capacity somewhere around about 5 to 10 kilowatt hours, and this is quite a small storage capacity that has to be bought for big money. Let's say it in that way. Even today, these kind of systems are quite expensive. As an alternative to batteries, MyPV can be used to use excessive energy in your building for hot water heating. And when we take a closer look, for example, on a 300-liter hot water boiler, and we increase the temperature in there for, let's say, 45 degrees centigrade, then this means an energy of 15 kilowatt hours that is saved in the tank. And this kind of storage capacity is already there where people are living. We have nothing more to do than installing the technology to make use of this storage capacity for your PV system. And MyPV is the developer and the manufacturer of this technology. So what is clear now is that MyPV can be a cheap alternative to conventional battery storage systems. That's clear, but we do not compete with battery manufacturers. It's pretty clear that stationary battery systems are a very important part of the transition to renewable energies of our society. And that's why we have started many of very successful corporations also with well-known battery storage manufacturers. And if these systems fit together, and we have many examples for this, then both capacities can be used together. And this means you have a maximum of self-consumption. There's hardly no energy wasted to the public grid. If there is a battery, only if there is a battery, then the battery charging has priority before the MyPV application. Why is easy to explain. Once it is heat in the hot water boiler or in the storage tank by our device, then we cannot get back electricity out of it. So we cannot reverse the physical process. And that's why there should be priority on charging the battery if there is a battery. Because once it is heat, we cannot make use of electricity again. And when it's not the middle of December in Europe, let's say we have a spring, summer, or autumn, then we see usually what we can see here on this diagram. Sometimes at the late morning, the conventional storage capacity of the battery is completely used. And so the state of charge of the battery is on 100%. And from this moment forward, for the rest of the day, we can make use of the excessive energy to create hot water with. So this is a far better way than selling the energy to the grid for no revenue, for nothing, or for shutting down the PV system, which is the worst of all options, because we are deactivating a renewable energy system. So this is the worst thing that can ever happen. We offer the solution to create heat out of this excessive energy that otherwise would be unused or sold to the grid. And if we do so, we can avoid the start of your conventional heating system in the evening. Worst thing is the gas boiler is started in the evening to prepare our hot water for our personal comfort. Why should he? Why should it? We already have made the hot water heating by a MyPV application during the whole day. So there are plenty of systems in our portfolio. One is a DC solution. It's on the market for many years, for nearly 10 years now. It's basically a plug and play DC product where you directly connect the panels. What I'm going to show you today is the AC ELWA 2, which means it's an AC product. It's not directly connected to the PV panels. It takes the power from the AC building installation, but it just takes the amount of power that is too much in your building. So just the amount of power that would be fed into the power grid is used by AC ELWA 2. And this means you already have an on-grid PV system, a grid-connected PV system, which also has an inverter, of course. And this system supplies your electric appliances with priority, and the rest of the energy, which is too much in the building, can be used by AC ELWA 2. And this is the topic of our webinar today. And there's a huge list of advantages when we compare it with the older generation, which is called AC ELWA E. You also see an AC ELWA E in my background. It's basically also a smart immersion heater in terms that it can control the power output on the heating rod linearly. And this is the top important thing when we are talking about power to heat combined with photovoltaic systems. You have to adjust the power output very fast and very accurate according to amount of excessive power. And this is changing permanently in your building from 1 second to the other, because the PV production on the roof, the power is changing. And at the same time, you're permanently switching on and off electric appliances in the building. And it's all about the excessive power, all about the balance in the feeding point, the amount of energy which is too much. And therefore, you have to adjust the power output here very fast and very accurate. Both units are able to do so. With the AC ELWA E, the maximum power output was 3 kilowatts. So every single watt between 0 and 3000 watt was possible. The first of the 4 main advantages of the AC ELWA 2 is now we have more power available. Now it's 3.5 kilowatts instead of 3 kilowatts. So 17% more power control is possible. This means, of course, more self-consumption ratio and more autonomy from your energy supplier, because you can use more of your energy in your building for yourself for heating. And it's still a single-phase product. With 3.5 kilowatts, it's clear that we cannot use a standard European socket where the device is connected to. It's now a manually wiring, and it has the benefit that the wire is made by the electrician. which means that it's never too long or too short anymore. And of course, you do not need the mains plug. There is no mains plug. Still, it is pluggable, but it is pluggable on the device itself now. And the plug where you connect the wire to is, of course, in the scope of delivery, no question. Okay, 3.5 kilowatts is still possible with a 16 amp fuse. For a 3 kilowatt unit, it meant a current of 13 amps. It's, of course, slightly higher with 3.5 kilowatts, but it's still within the range that is covered with a 16 amp fuse. So more power, first of four main benefits. Second one is it's obvious. We have a display on the AC ELWA 2, and once should be explained as well here on the first slide. The size of the box which contains our power electronics for the linear power control is now smaller. So do not get confused because of these two images here. The box of the AC ELWA 2 is smaller than the green box of the AC ELWA E. But what I was intending to say, it has a display on the device. Some of you might already know the display from our Actor product group. So Actor and Actor 9S, they have exactly the same color touch display on the device. And the lessons learned from the Actor was that this display is so much important for both people who are working with the device. Number one, the installer, and number two, the end customer who owns the device. What is the advantage for the installer? It's a direct user interface you have on site. So we thought about using a Wi-Fi spot or a Bluetooth connection to do the settings via your smartphone. There can be troubles with this kind of setup. So we really thought about it and decided to keep the display from the Actor. And for all of you who are already familiar with installations on site, you go to a location and you have no clue about the network there, about the router settings. You do not know the IP address of AC ELWA E when it's connected to the router. And here you have the user interface, and it helps you going through the commissioning steps. For example, you have the info. Is there already an IP address received from the router or not? You can adjust the IP address of the device itself, of course, also on the display. There is still the external web interface, which you probably already know from AC ELWA E. But beside the conventional web interface, there's also always the way to do the setup on the display. So much easier to handle for the installer, for the electrician or the plumber or whoever is commissioning the device. And number two, for the owner of the device, for the end customer, because it's very easy to go through this menu here. It's very intuitive to adjust things like the target temperature, for example. You do not have to read the manual to have an idea of this. It's self-explaining and very intuitive. So, main advantage number two. Main advantage number three, we have Wi-Fi also. So, for all of you who were not aware of this, the E of AC ELWA E meant Ethernet. So there always was a patch cable, an Ethernet cable, which was connected to AC ELWA E, and the AC ELWA E receives the control signal via the local area network. It's always hardwired. There's always the question from the customer side to have Wi-Fi as well. And that's, of course, an idea or something that we do and that we can now with AC ELWA 2. There's a Wi-Fi antenna also included in the scope of delivery, of course. And nevertheless, there's still the option to connect the device to the signal source via LAN. So you have to do either this or that. And so why why did we decide to keep the LAN port? You have to imagine where the device is mainly installed. Probably it's somewhere installed in the basement. So, and in between the AC ELWA AC ELWA 2 and the signal source, there is maybe a concrete level. So which causes problems for the Wi-Fi connection, of course. And that's why we decided to keep the LAN port optionally as well. Okay, last but not least, the fourth main advantages is that we have now separated the professions. One problem of AC ELWA E was the connection between the electrician and the plumber. So the plumber looked on the device and said, "Ooh, there's a LAN port there, there's a wire there, this is not my business." And the electrician on the other side said, "Okay, there's a 1.5-inch connection thread, something needs to be uh, assembled into a tank. That's not my business." And now we decided to separate both professions, which means that the heating rod and the electronics for the linear power control are separated in the beginning. Of course, both things are in the box, and this is very easy to explain because we have prepared an assembly video for you, and this is what I'm going to show you now. So, movie starts.
The AC ELWA 2 is a 0 to 3.5 kilowatt linearly controlled water heating device for grid-connected photovoltaic systems and is the successor to our proven AC ELWA E. Thanks to an improved power unit, the AC ELWA 2 has a higher power capacity. With the ability to manage more power comes the ability to optimize self-consumption of the energy your current PV system generates. The AC ELWA 2 harnesses your PV system's surplus photovoltaic energy to heat your water, further increasing self-sufficiency and ultimately reducing your reliance on traditional energy providers. The ease of installation is another core feature that sets the AC ELWA 2 apart from similar devices. It consists of two components that are installed sequentially. For example, to facilitate installation in the hot water tank, the heating element is initially separated from the electronic unit. Following that, the electronic unit is installed. The AC ELWA 2's color touch display is the next important feature that you're already familiar with and appreciate from our AC Thor. The touch display makes viewing and changing your device's settings straightforward and intuitive. In addition, the AC ELWA 2 has been equipped with Wi-Fi. This allows it to communicate wirelessly with the signal source. Of course, the familiar Ethernet interface is also integrated. Visit our website to learn more about the AC ELWA 2 and all of the advantages it has to offer.
Empowering the solar future.
All right, so there are four advantages: more power, display, flexible control, and we have the separation of the professions. So anyway, there are still more advantages, and here we have also an overview of the communication possibilities, because it's not only about LAN and Wi-Fi. To sum up, how the AC ELWA 2 can be communicate with the signal source, we have this list here. And this is also already interesting for one question in the chat. So one way to detect the excessive power information in the feed-in point is the MyPV Wi-Fi meter, which is a little meter for DIN rail installation. And with this meter, you are completely independent from the PV inverter. We just meter the excessive power on our own, completely independent from the type of inverter. It can even be used with a wind turbine or whatever. It's just about the excessive power that we are detecting ourselves in the feed-in point. But we do not need to use the MyPV Wi-Fi meter. Many of smart home systems, battery management systems, and inverter manufacturers have already implemented our communication protocol into their controls. And therefore, there are other ways to communicate. For example, we are free programmable with Modbus TCP, also via HTTP. Both of these communications are connected either via LAN or Wi-Fi, which also is the case for the MyPV Wi-Fi meter. And also via LAN or Wi-Fi, we can communicate with energy storage systems, smart home systems, or inverters. Beside those two that are already mentioned with the four main advantages, there are two other ways to control AC ELWA 2. Number one, RS485. There is the possibility to communicate with Modbus RTU, as the engineers call it. And in that way, it's also possible to receive the excessive power information either from compatible inverters, energy storage systems, or smart home systems. So it does not need to be controlled via LAN or Wi-Fi always. You can connect it via RS485 as well, and it will be good. And beside those three ways, there's a fourth alternative to set the power output of AC ELWA 2. And this is a PWM input signal, where an external control has the intelligence to know how much excessive power is available. And via PWM, you just set the power on AC ELWA 2 that your system wants to have. So then the whole logic and the whole intelligence is in the superordinated control, and we are just the smart immersion heater which reacts accordingly. So 4 ways of communication: LAN port, Wi-Fi, RS485, and PWM is possible to set the power output on AC ELWA 2. Technical details. I already mentioned a few of them. Number one, linear power control. It's all about linear power control. Forget every direct electric heater, which is just switched on and off. It has nothing to do with PV-ready applications. It's always about linear power control. So from 0 to 3,500 watt. There is also a relay switch for 16 amp. You see it on the bottom here. Beside the main supply connection on the left, there is a relay available where you can switch a second immersion heater with up to 3 kilowatts maximum. More on this application later. Then the connection to the mains is single phase, as I already mentioned. And here you see where the plug is plugged into the unit. So the power supply from the AC building installation comes from here. Beside the relay for the external immersion heater, there's also a relay with a safety extra low voltage, and it is here. That means for times where you do not have enough excessive power from your PV installation to do the whole hot water heating, you have 2 other options where you can choose. Either you want to do the boost backup to ensure your comfort with AC ELWA 2, or you want to do it with an external heating source, whatever it is, a heat pump, a biomass boiler, whatever. And to send the start signal to this external heat source, there's a safety extra low voltage relay included at the bottom here. Then there's a safety temperature limiter that is now resettable. Every direct electric heating system needs a safety temperature limiter for safety reasons. From our experience with AC ELWA E, this STL is very often triggered by external heating sources. Let's say solar thermal systems, solid wood stoves, or combined heat and power systems. This kind of heat sources, they go up to the top limit with the tank temperature, nearly to 100 degrees centigrade. And this is the point where the safety temperature limiters are usually triggered. And for the AC ELWA E, this meant that we have to replace the temperature sensor in the device, which of course means effort for all people involved. Now, this safety temperature limiter can be resetted on the display once this is triggered. What's also included in the scope of delivery is an external temperature sensor. When we go back to the bottom view, this is connected here, and this external sensor has a length of 5 meters. Already mentioned, it has a display beside the normal web setup that you are already used to, and of course it is possible to connect AC ELWA 2 to the MyPV cloud for remote access, also from outside the local area network. What is always an option is the option for backup power to ensure your minimum comfort. The factory preset is that this option is deactivated. When the device is supplied from MyPV, it comes in a configuration where only excessive energy is used. But with a few clicks on the display, you can activate the boost backup mode if you want. Very important to say that MyPV is always doing the linear power control with pure sinusoidal current consumption. This means we have no thyristors installed. We have no phase angle control. This is very important, especially for Central Europe. In Austria, Germany, Switzerland, it's not allowed at all to use thyristor controllers for this amount of power. And with our solution, our customers can rely that the manufacturer has made his homework. In that case, we did. Mechanical data, as the AC ELWA E, also AC ELWA 2 has a 1.5 standard, 1.5 inch, standard connection thread. This is a very common size of the thread on hot water boilers and on storage tank. The heating element inside the thermal storage has a length of 45 centimeters. This is also equal to AC ELWA 2. What has changed is the unheated zone at the beginning of the heating rod. From the connection thread onward, we have 14 centimeters which are cold. They are not heated. And this is very important for the installation, not so much in hot water boilers, because usually the insulation is pretty thin, let's say 8 centimeters or so. But for a big storage tank, we often see insulations from 100 millimeter, 120 millimeter in some cases. And this was critical for the installation of AC ELWA E, because the non-heating zone was sometimes too short. And with AC ELWA 2, we have now extended the unheated zone to 140 millimeters. And this makes it easy to use the device also in storage tanks as well. Here is a hyperlink. You can make use of this link after the webinar. Once I have provided the slides that you see right now, I'm going to send the slides to you via email. And with the link here, you can directly open up the data sheets for more technical information. I have already described the connection area at the bottom. This was quite theoretical, probably for you. Now I want to show you what it means in practice. The Actor product group comes with 7 operation modes, and we use 2 of these 7 operation modes from the Actor in AC ELWA 2 as well. And that's why we have this description here, operation mode 1. It's the hot water mode. And of course, this means a power output of 0 to 3.5 kilowatts, as mentioned already several times. And in the first step, I want to show you how this is used without using the external sensor that is in the box. So when you use it without a sensor, without the external sensor, it's basically working exactly as AC ELWA E. There's always one sensor also directly in the heating rod. And when you do not use the external sensor, this means that this sensor in the rod is responsible for everything. It's responsible for the excess power heating, and it's also responsible for the optional boost backup mode. and also for the optional Legionella protection if you want to make use of this. But the target temperature that can be set on AC ELWA 2 is the same principle as we have on AC ELWA E and on Ector. You can set two target temperatures, a higher one for using excessive power from your PV system and a lower one just to ensure your comfort with the optional boost backup mode. What benefits does this mean? First of all, you reduce the energy from the public grid to a minimum if you use this optional boost backup mode. When you just use excessive power, there is no energy from the public grid at all, to be clear. But if you activate this optional boost backup mode, you can heat up to a minimum, and therefore there are 2 time frames per day available. And once you have excess power, you go up even higher with the temperature. And this means your solar coverage ratio gets better and better. For the use in hot water, in fresh water, I would recommend not to go above 60 degrees centigrade. Why? Also for AC ELWA 2, calcification can be a problem for the heating rod. This is the case for all electric immersion heaters. And to ensure your comfort, you can set your boost backup mode, let's say, to 45 degrees centigrade, 50 degrees centigrade. You reduce your energy demand from the public grid when you use this optional boost backup mode, and you always have a gap left to make use out of your excessive power. And with these 2 facts, your solar coverage ratio becomes better and better. Now I'm going to show you what is possible when you make use of this external sensor that comes with the device. The minimum temperature in your tank is now not connected to the sensor in the heating rod. It's now connected, or depending on the sensor value, from the external sensor. Why is that? You make your solar coverage ratio even more better, because now you just ensure the minimum temperature in the upper area of the tank. And this means that the bottom area remains always cold to have free storage capacities for your excessive PV power. And once you use this external sensor, and it always needs to be installed somewhere on the tank above the heating rod, of course, otherwise you would not measure anything. Once you use this, you have a third option here for the boost backup. Option 1, it's always deactivated with the default presetting. Option 2, you use the AC ELWA 2 to ensure your minimum comfort, but now there's the third option. Now you can make use of this safety extra low voltage relay, which can start an external heat source, which means to ensure your minimum temperature on sensor number 2, you do not need to use energy from the grid. You can also use this relay to start your heat pump, your biomass boiler, whatever. Okay, so it's much smarter when you use the external sensor as well. Anyway, for tanks where there is no place to install it, it's also possible to make use of the AC ELWA 2 as described here, but if possible, we recommend to you to use this external sensor. And this is operation mode 1. For the Ector, for example, I would say nearly 90% or more of all devices are working with mode 1. And this mode, of course, can be used in hot water tanks or in storage tanks, or in hot water boilers with fresh water, or in storage tanks where also the hydronic space heating is supported somehow. Okay. And then there's mode 3. There is no mode missing. I directly switched from mode 1 to mode 3 because I already mentioned we took the operation modes directly from the Ector. As they are in Ector, they are now used in AC ELWA 2, at least 2 of them, and mode 2 is not possible with AC ELWA 2, but mode 3 is. And this is the mode where we make use of this external immersion heater that I already have mentioned. Remember, I'm moving back on the slides. I told you that there's a relay contact for an external immersion heater. This is not a smart immersion heater. It's not linearly power controlled. It's just a switched one. And when you make use of this connection here, and when you make use of an external immersion heater, you expand your control range. And the way this works is described here on this diagram. Let's assume you have excessive power available somewhere in between 0 and 3 kilowatt. AC ELWA 2 will perfectly do the job, and it's always ensuring the balance in the feed-in point. Now imagine you have more excessive power available because your PV system is pretty big, and now the sky becomes clear, and we have perfectly conditions. Once we have more than 3 kilowatt of excessive power available, we now close the relay for the external immersion heater. And from this moment forward, we start the linear power control on AC ELWA 2 from 0 again. Overall, or in sum, or in total, this means a controlling range of the power from 0 to 6.5 kilowatt. With using just one AC ELWA 2, you have a control range from 0 to 6,500 watts. In this mode, both immersion heaters need to be installed in the same tank, and the external temperature sensor needs to be used every time, and it needs to be installed above these two immersion heaters. Otherwise, it would not measure useful values. The option for boost backup is now either off, as the default setting is, or on, and when it's on, it's meant that both immersion heaters are used with maximum power, because the goal is to achieve your minimum comfort temperature as fast as possible. All right. Overall these applications, there's always the general question: why does it make sense not to feed surplus into the power grid? And there are several reasons for this. There are economical reasons. For example, feed-in tariff. What does it mean? Let's assume that the feed-in tariff becomes lower and lower and lower, as our neighbors in Germany are experiencing. And at a certain point, you do not get so much money that this is still interesting, especially at the point where the revenue for feeding a kilowatt hour into the grid is lower than the cost for your conventional heating source. When you look into the media nowadays, you see the gas prices are exploding, and when the price for a kilowatt hour out of natural gas is higher than the money you get for feeding a kilowatt hour into the power grid, then it's immediately interesting not to feed in. You use this kilowatt hour in your building, and you make heat out of it, and you directly replace one by one the kilowatt hour from the natural gas. So it's economically immediately interesting to do so. And this economic motivation was a huge motivation for most of our customers in the past. What happened this year in Eastern Europe moves everyone, and it costs a little change of the priorities for us. Now, also energy independence is a trigger for the sales decision for our clients. This was always a motivation to buy MyPV products, but it was never that important as today. So you getting more independent, more autonomous from your energy supplier by using the energy for your own in the building. So this is, let's say, a political motivation beside an economical one. Finally, there are always also technical reasons not to feed it into the power grid, because grid stability is a topic. So we have more and more PV systems on our roof. Luckily, we need to speed up this process even higher. We need to cover all the roofs we have with PV panels to make us self-independent from external suppliers. But once we have covered all our roofs with PV panels, one thing is clear. From a technical point of view, these buildings are not going to be able to feed into the grid. The grid is not designed for this kind of power. And this means that we need to keep as much energy from our panels in our building. We need to avoid the shutdown of the PV system as far as we can. And this means we need to make use of every storage capacity we can get. The battery is just the standard one for people who can afford it. But now we can make use of the hot water boiler and the storage tank to increase our self-consumption ratio as well. And these storage capacities are already there. We just need a technology to make use of this storage capacity, and MyPV is the manufacturer of these technologies. Anyway, it's all about excessive power that would be fed into the grid. And there was this question, are we independent from the manufacturer of the inverter? Yes, we are. If we do the excessive power detection in the feed-in point with the MyPV Wi-Fi meter, it's completely not important what brand you have for your PV inverter. We just detect the excessive energy in the feed-in point on our own, and we are supplying our devices with this kind of information. But it's not always required to use this Wi-Fi meter. It's an accessory part from our perspective, because there are plenty of other options to meter the excessive power in the feed-in point. And now there's the MyPV philosophy to be open for third-party controls. And this is really a successful history already. From the moment where we started with AC ELWA E, we were open for the control by others. And this means that we are even providing people with our communication description. For example, a smart home system wants to include our product into their control. MyPV is giving the communication protocol. No problem from our side. All right. Last slide before Talal takes over again. Now you probably want to know what this means for your projects or for the requests from the customers that you receive. There is this online calculator on our website, which is the MyPV Power Coach. Until we release the AC ELWA 2, it's of course possible to do this kind of calculation with existing system types on the MyPV Power Coach. For example, Actor with immersion heater. You just choose this system type, and you can calculate, you can simulate your project, but you can expect that it's getting much better with AC ELWA 2. Self-utilization ratio will be slightly higher. Independence ratio will be slightly higher because we have a bigger power control range, actually. Yeah. So this is the way to answer the request from the customer side. The people want to have an idea or an understanding what benefits it means to have a power to heat system from MyPV. You can even do an economic calculation here by calculating the operation costs. You can set a price for your conventional heating source. You can set feed-in tariff or electricity rate, and you see here what annual operation costs your whole building triggers. You can set variants to compare different systems together, and this is completely free and accessible for everybody without the registration. Only if you want to receive a PDF sample report via email, it's required to enter your email address. Otherwise, you can make use of this calculator anytime, anywhere, even without registration. It's a tool. I really recommend it to you because it gives you an idea of the possibilities and of the advantages by using MyPV power to heat systems in residential buildings. All right. And now there have already been some sales questions, Talal, in the chat. People already wanted to know when we can deliver AC ELWA 2. They wanted to know the prices. Now it's up to you to handle these questions. So please take over from now forward. And ladies and gentlemen, this is the end of my part. It was a pleasure for me from my side, and thank you very much. Talal, back to you.
Okay, taking over. So yeah, there were a couple of questions. It makes sense when the product is there and when the availability will be there. So the rollover for the new AC ELWA 2 will start take place next year by April or May. So yes, it will start in a short period of time. So there are questions what will happen to the existing order from the AC ELWA E. Yes, those orders will be rewritten, and depending upon the delivery time and those which coincides material and those things, so they will be rewritten to the AC ELWA 2. So in case if the customer cancels the existing AC ELWA E, unfortunately they and they order back the AC ELWA 2, so they will go back in the line because it's first come first serve, and we need to um, overlook this thing also. And the price are the same. So generally when it's next generation, more usually the prices are more, or like they are more than the existing one, but that's not the case with the AC ELWA 2. So the prices are the same as with the previous one, so there's no difference in terms of pricing. As the AC ELWA E, our recommended end customer price is 693 euros. Same will be for the AC ELWA 2. And yes, the delivery will start take place next year, hopefully by April and May. That is the plan, and hope so that we will be doing more with the AC ELWA 2. So in the end, I thanks would like to thank you, our sales partner, and interesting on the for so many years, and together with the 6 years of experience with the AC ELWA E, obviously there's more into the knowledge, more into the background, more into the development for the AC ELWA 2, and that's how we are. It's naturally more promising for the next model. Okay, so from my side, it's evening time by Austria. So wherever our viewers are, wishing them a nice evening, good morning, depending upon their time. And stay contact with us. You will get the slides as Reinhard mentioned. And let's keep in touch for the next year also.
We're looking forward to it. So thank you very much. Have a nice evening. Take care of yourself, and all the best from Talal and me from Upper Austria. Goodbye. Ciao.
Empowering the solar future.